In this video, we're going to do elimination to solve our systems of linear equations. So this is just another method. Sometimes it'll be very difficult to use substitution because it's very difficult for you to isolate a variable, meaning solve one of these equations so that you have y equals or x equals to do the substitution. So sometimes it's actually easier to just do elimination, which is the method I'm going to show you right now. So again, you probably took notes on this already, but if you didn't, or you have a little extra room, I'd probably take down these 3 problems as 3 extra examples, and then you'll be able to do the assignment that I've assigned for you today. Okay, so elimination. Elimination is just like how it sounds. We're going to try to eliminate, like cancel out one of these variables by adding these two equations together. I'm going to literally add them like I'm adding numbers, okay? The other method was substitution. That's a little different. I'm substituting one of the variables with an equation or with a number, right? I'm like plugging it into the other one. But this is not it. We're not plugging into one another. We're literally trying to add them together, and then you'll see that one of the variables will hopefully cancel out, which is what we want, or eliminate out, right? So first, we need to eliminate one of these variables. It's so it doesn't. Sometimes it's easier to eliminate the x value. Sometimes it's easier to eliminate the y value. In this first example, it's easier to eliminate the x value, okay? We are going to try to add straight down, or at least add all the x values and then add all the y values of both equations, and we're going to try to eliminate this x value. So what we want to try to do, if the question isn't already done for you, you want to try to line up the x values on top of each other and line up the y values. It's easier to see what happens when you line them up, okay? So when I add them together, we're going to add straight down, and you're going to see that the x values cancel out, they eliminate. Negative 4x plus a positive 4x gives me 0. That goes away. Okay. And then negative 2y plus 8y gives me a positive 6y. And we're just going to add the rest of this, so equals negative 12 plus a negative 24. So you're adding 2 negatives, so that would give you a negative 36. So if you notice, by adding these 2 equations together, I was able to eliminate that x value. Okay, and now I just have y. So 6y equals negative 36. I can solve that. Y equals negative 6. Just like in substitution now, we're going to plug this y value back into one of these equations. Okay. Doesn't matter which one. One of them's easier than another, but you can actually plug into whichever one, and it really doesn't matter. You'll get the same answer. Okay, so I'm going to plug into the second one. 4x plus 8y equals negative 24. I'm going to plug it y into this equation. So I'm going to plug it into here. And you get 4x plus 8 times negative 6 equals negative 24. And I solve for my missing variable, my x value. So 4x minus 48 equals negative 24. 4x equals positive 24 because I added 48 to both sides. And then I divide by 4, so x equals 6. Right, so I have my x, I have my y value. I'm going to write it as a final answer, 6 comma negative 6 as my answer. Okay, so that's what we're looking for. We're looking for a variable to eliminate when I add them together. Okay, so for this next one here, Let me just make sure this is right. Okay, yeah. So for this next one, I want to make sure that I have a variable to eliminate. Right now, I'm checking myself that I can't do substitution because it's really hard for me to isolate any variable here. So it's going to be easier probably to do elimination. So I want to find out which variable to eliminate now. Now I'm looking at these two. I have 8x and 6x. I have 14y and a 7y. Now we want these numbers in front of these variables to match up. Okay, just like here, the 4 and the 4 matched up, and I was able to eliminate that. So that's what we want to replicate. Now, which one is actually easier to match? Right? Is it the x values that are easier to match, or the y values that are easier to match? It's going to be the y values because I want to multiply to match it up. I don't want to add numbers to match it up. So if I look at 14 and 7, I can multiply 7 by 2 to get to 14. So I'm going to do that. I'm actually going to multiply the entire equation by 2. I want to multiply the entire thing by 2 because that will keep the problem the same. If I just change 7 and I just multiplied 7 by 2 and I kept everything else the same, I kept it as -6 and I kept it as -10, but I only changed the 7 to a 14, that changes what the problem is. It changes the entire equation, and I don't want to do that. I want to keep the problem the same, but just modify and manipulate it so that it gets us what I want. So I'm going to multiply the entire thing by 2. So my new equation is going to be -12x minus 14y equals -20. Okay, so these are my new equations that I'm going to use. I'm going to next combine or add these two equations, and hopefully my y variable will get eliminated. Okay, so let's see, 8x plus a -12x gives me -4x. 14y plus -14y. That eliminates. 14y plus a -14y gives me +0. Okay. 4 plus -20 gives me -16. So we did the elimination. We eliminated the y variable. So now we have -4x equals -16. And I can solve for x. X equals a +4. So just like the previous step, I solve for my first variable. Now I plug in that variable into whichever equation you want. You can plug it into my first equation here that I was provided. I can plug it into my original second equation. I can even plug it into my modified equation because it technically is exactly the same as this, okay, as their original second equation. So you can plug it into any of those. I want to plug it into the, let's see, the first one. I'll plug it into the first one. There's more positive numbers, so I prefer that. So I'm going to plug x equals 4 into 8x plus 14y equals 4. I'm going to plug this into that x value. Okay, so new equation would be 8 times 4 plus 14y equals 4. And I'm going to solve for y. 32 plus 14y equals 4. 14y equals -28 because I subtracted 32 to both sides. And y equals a -2. So I have my x, I have my y value. I write as one answer, 4, -2. Perfect. Okay. Example 3. Okay. So this is an example of elimination again. I can see that it's a little bit difficult to solve for elimination. Now I'm going to give us a quick tip. If you have a GCF, a greatest common factor for the equation, right, you want to try to divide that out first. So you want to simplify, because sometimes it is easier with smaller numbers than bigger numbers. Okay, so what we can do here is let's simplify this and let's divide by 2. So even in these previous problems, we could have done the same thing. We could have divided this equation by 2, since there's a greatest common factor of 2. We could have even like divided this by a 4, since you have a greatest common factor of 4, and your answers would have been the same. Your process would have been a little bit easier because your numbers would be smaller, but do try to look for those. Sometimes it does make the problem easier. Okay, now if you didn't simplify each of these, you can still do the problem. You would just have to find a number that both of them would be able to multiply to. So so an example is, if I'm looking at 2 and 5, and I want to try to match up the numbers just like I did for 14 and 14, you're going to have to actually multiply both equations by a number instead of just one equation. So I would have to multiply the top equation by a 5, and I would have to multiply the bottom equation by a 2, right? And you would still get a right answer. It's totally fine to do. Sometimes it's actually easier to simplify the problem first and then see what you can work with later, because the numbers are smaller. So what I'm going to do is I'm actually going to divide by the greatest common factor at the top, which is a 2, and I actually have another greatest common factor for this bottom one. Greatest common factor for this bottom equation is a 5. So I'm going to divide each of those and simplify it down a little bit. Okay, so my top equation will now be x plus 4y equals 3, because I divided all those numbers by 2. My new equation for the second linear equation is negative x minus 4y equals negative 3. Okay, and let's see what happens. So now I have two equations. Now you guys might be tempted to do a substitution at this point, but it's actually already set up very nicely for us to do elimination. So we might as well do elimination. Okay, I'm going to add these two equations together, and you're going to see something happen here. I'm going to add my x's together, and it becomes 0. I'm going to add my y terms together. That also gives me 0. And I'm going to add the 3 and the negative 3 together, and that also gives me 0. So what I have here after elimination is that I have 0 equals 0. Now, previously, I said that when two numbers are not equal to each other, like when it was 9 equals 4, it was no solution. But this time, it's 0 equals 0. 0 always equals 0, right? So this is always true, meaning you have infinite solutions. Right? Infinite solutions. It'll always be true. There's no variable to plug in. So anytime you plug in another number, it'll always be 0 equals 0. So it is infinite solutions. All answers will work here. And that graphically, if I look at a graph, these are two identical lines, right? So that means they're overlapping each other. They're what we call coinciding with each other. We talked about this when we did graphic. So these are 3 examples of elimination, one with an infinite solutions. Hopefully this helps. You can, go back, replay this video if you need to, and try the assignment that goes along with this.